Hi there, pre-calculators and trigonometers. I am here to talk to you about finding complex roots of a number written in polar form with DeMoivre's theorem. And basically, this is what we're going to use. This is, if you think about what we've done in the past with DeMoivre's theorem, which is basically raise things to a power, it's basically just going in the opposite direction. It's taking the root instead of going to the power. But it's kind of complicated looking at first here. So let's just look real quick at what it's trying to say. First of all, whatever your number is out front, you're taking whatever root it is of that. For instance, if the problem says you're going to take the cube root, then you're taking the cube root of the number out front, and n is 3. If it says you're going to take the square root, then you're taking the square root of the number out front, and n is 2. Then you're going to take your angle, and you're going to add either 2 pi, if you're working in radians, or 360 times k, starting with k is 0. So the very first one, you're going to just add nothing, because times 0 is just going to give you 0. So you're going to take your angle, and then you're going to divide it by whatever root you're working with. Square root, you divide by 2. Cube root, you divide by 3. Fourth root, you divide by 4, and so on. You're going to do this again. You're going to do that whole thing. You're going to do it again for k is 1. So you're going to go back and you're going to do the same thing here, but the difference is this time you're going to say my angle plus 2 pi or 360 times 1 before dividing by n. You're going to do this all the way up until when you get to 1 less than whatever root you're doing. So for instance, let's say I'm being asked to do a cube root. Then I'm going to do a cube root means my n is 3. So n minus 1 would be 2. So I'm going to do 0, 1, and 2 and stop. Cube root, you'll have 3 answers. If I was going to do a square root, that would mean my n is 2. So I would do 0 and 1 would be n minus 1. So I'd stop there. Okay, so it just so happens that the examples that my students need to do are all in degrees. So I wanted to show you the formula in radians because it works exactly the same way, but the examples we're going to do are going to be in degrees. All right, so it'll look like this. Find all the complex square roots of, and then here is my complex number. W equals 100 times the cosine of 30 plus I times the sine of 30. And I'm being told to write my roots in polar form with theta in degrees. Okay. So I went ahead and rewrote the formula with 360 because we're dealing with degrees here instead of 2 pi, but that's really the only difference. All right, so if we're finding the square roots, that's the first thing I need to know is what root I'm being asked to find. Square roots means that n is 2. Okay, so I'm going to start out, remember we start out with k is 0 and work our way up to n minus 1. So we're going to have to do it for k equals 0 and for k equals 1, which means we're going to have to do this formula twice. We're filling it in first for k is 0 and then for k is 1. So for k is 0, my answer is z sub 0. So that's basically just saying which answer I'm on. I'm on the first answer, k is 0, is equal to the square root of the number out front. The square root of 100 is 10. Notice that's not going to change as k changes. So I'm going to have a 10 out front regardless. Then I have the cosine of my angle here, theta was 30. 30 plus 360 times 0 is still going to just be 30, but I have to divide it by n, and n here is 2. So my 30 gets divided by 2 and I get 15. Plus, and then the same thing happens for what I'm taking the sine of, same angle. So that's my z sub 0. But I have to do it for k is 0. This is for k is 0. And I also have to do it for k is 1. For square root, I'm going to have 2 answers. So now I go back and I do the same thing for z sub 1. Let's see if I can fit this a little bit better. Again, the number out front is the square root of 100, so that's not going to change. What is going to change is what happens here. I'm going to take theta, which is 30, and I'm going to add to it 360 times 1. K is 1, remember. 30 plus 360 times 1 is 390. Then I'm going to divide by n, which is 2. 390 divided by 2 is what? 195? Yes. So 195 plus I sine 195. And those are my answers. And those are both answers. For square roots, I'm going to have 2 of them. If this had been a cube root question, I would have 3 final answers. So let's do one of those next. Okay, so this problem is very similar. The only difference is that it's asking me for cube roots. So when they tell me cube roots, that means that my n is 3. Okay, so I'm going to show my formula again. And this is theta. This is r. What else have I got in there? And k is going to start out, remember k starts out with 0, and it goes until we get to n minus 1. So I'm going to have to do this 3 times. I'm going to have to do it for k is 0, for k is 1, and for k is 2, because that's 3 minus 1. So first one, we're going to call this, we probably should call it w sub 0 instead of z sub 0. So w sub 0 equals, it really doesn't matter. We can call it z sub 0 either way. First off, the cube root of r, that's the same for every single one. So the cube root of 8 is 2. So I know that every single one of these is going to start out with a 2 up front. That's not going to change. All right. Next, I'm going to take my original theta, and I'm going to add 360 0 times, which means I'm not going to add 360. So I'm just going to have 180 divided by n, which we've already said is 3. 180 divided by n is 60. So this is going to be cosine 60. So this is my first answer. And then I'm going to go back and I'm going to do it again. And the only thing that's going to change is k. So this time when I'm going to take my theta, 180, and I'm going to add 360 one time. 180 plus 360, I should know off the top of my head, is that 540? Yeah. So it's 540. 180 plus 360 is 540. Divide by 3. So 540 divided by 3, I'm starting to not trust myself. So I'm going to use a good old calculator here. 540 divided by 3 is 180. Well, that makes total sense, doesn't it? 180 plus 360, which is 180 twice. So we have cosine of 180 plus I sine of 180. And then the next time we're going to add 360 twice. So 180 plus 360 twice is 180 plus 720. Or you could do 180 plus 2 times 360. That's 900, and then divide that by 3, and we'll have 300. Okay, so now this is how we were asked to write the roots. Polar form with theta in degrees. Now, if I had been asked to write these in rectangular form, basically I would go ahead and I would multiply this 2 times each, and I would say 2 times cosine 60. That's my x, basically, or my a. Think about a plus bi. So this would be 2 cosine 60 for the first one, and this would be 2 sine 60. And I wouldn't do anything with the I. And then for the second one, 2 cosine 180, 2 sine 180, and so on. Okay, I'm pointing that out because the very next question we are doing does exactly that. It asks us to give our answers in rectangular form instead of polar form. So let's try that one. Okay, so I wanted to include this one because it's a little bit weird, maybe. Find all the complex cube roots of 1. Write the roots in rectangular form. The first problem with this one is 1 is not written like this, and this is what the formula is based on. So I'm going to have to figure out how to write 1 like that. Okay, so the first thing I'm going to do, and I'm going to kind of come down here and do it, is I'm going to think about 1 in terms of a plus bi. Okay, so that means 1 plus 0i. So in terms of coordinates, in terms of on a graph, that would be in X and Y, 1, 0. Well, 1, 0 on a graph means right over here. So let's think about what R is there and what theta is there. R, remember, is your distance from the origin. So R is 1 at that point. Theta, well, we start here for theta. So theta is 0 here. So this point is still 1, 0. It's like 0 degrees if we're going to do it in degrees. So that's what we've got here. Now remember, this is R, this is theta, and the way that these are written is R, the way the problems we've been writing are polar form, is like this. So we just said the R is 1 and the theta is 0. Sorry, I accidentally wrote theta. That's a 0. Okay, so that's what basically the number I'm starting with is. And then that's the number I'm going to apply this formula to. Now, that shouldn't look like a theta. Remember, that's 0. So the interesting thing here is, first of all, cube root n is 3. When I take the cube root of 1, I get 1. When I divide 0 by 3, I still get 0. So my first answer, z sub 0, is 1 times cosine 0 plus I sine 0. My second answer, I'm going to do the same thing, but this time I'm going to add the 360 because k is 1. So I've got cube root of 1 is still 1 out front. And then I've got 0 plus 360 times 1, which is 0 plus 360, divided by 3. Well, 360 divided by 3 is 120. And then finally, because for cube root, I've got to go up to k is 2, which is n minus 1. Cube root of 1 is 1. And then I've got 0 plus 360 twice. 360 twice is 720. And then 720 divided by 3 is 240. So this is going to be cosine 240 plus I sine 240. And there's a dog here on my piece of paper. Sorry about that. Okay, so now these are my answers, but we were told to put these answers in rectangular form. So just like I was talking about in the last one, rectangular form here is basically, if you think about it, it's kind of like distributing the 1, which distributing 1 doesn't do much, but it's like writing, I don't know if I want to use that space. I guess I do. 1 times cosine 0, keep trying to make it a theta, plus 1 times sine 0 times I. So this is basically a plus bi. So my a, 1 times cosine 0, the cosine of 0 degrees is 1. Remember that cosine sine is what happens when we have our rotational angles there. So cosine of 0 degrees is 1. So 1 times 1 is 1. So this is 1 plus, and the sine of 0 degrees is 0. 1 times 0 times I is just going to be 0, so there's my first answer. The next one, 1 times cosine of 120. Cosine of 120 is negative 1/2. 1 times sine of 120, sine of 120 is root 3 over 2. And then we have I. Cosine of 240. Cosine of 240 is negative 1/2. Sine of 240 is negative root 3 over 2. And I. Now, if you're in my class right now and trying to do the MyLabs Plus online, let me point out to you, when you put these in, it's actually asking you to put them in as a decimal, which is pretty weird, quite frankly. So you would be asked to put this in a decimal, rounded to the nearest tenth. So this would become 0.5 and this would become 0.9. So I hope that helps you out on these. And thanks for coming. Thanks for watching. Happy to see you here. And feel free to leave me a comment and check out my other videos.